Okay, in this one you need to recall the formula for momentum. Momentum is mass times velocity. Be careful if you're going to use symbols that momentum has a symbol P, little p. Then it says calculate the momentum. Well, we need to plug in some numbers, so we get our numbers from up here. The mass is 0.15 and the velocity is 6, so multiply those together and we get 0.9. Next you have to worry about the units. If you're not sure what the units are, look at the two things you're multiplying together. We're multiplying kilograms and we're multiplying that by velocity, meters per second, so the combined unit is kilogram meter per second. Okay, this question is about conservation momentum. So in any of these, any time you're trying to solve one of these problems, so there's some collision involved, the total momentum before the collision equals the total momentum after the collision. Now before the collision we've worked out the momentum of the cloth, which is 0.9. And that equals the momentum of the cloth and tin combined afterwards. Well, the both cloth and the tin are moving at the same velocity, so we can combine the mass. So this is the combined mass, 0.15 plus 0.05 times their combined velocity. And if you rearrange this, you get V equals 0.9 over the combined mass, 0.2. Gives you 4.5, and then the units meters per second. Well, you don't need units, they've given you units. Okay, this last question is about the student's conclusion. He's saying, I threw the cloth the same way, so that the velocity of the tins 2 and 3 is the same as the velocity of tin 1. Is his conclusion correct? Well, it isn't. And the problem is that he hasn't controlled the variables, so he's not kept the variables that he had in the first experiment with the second one. So for example, the mass of the cloth might be different, maybe the mass of the tins that he was hitting is different, and we have no idea about whether he said he threw it in the same way, but we have no idea whether the velocity of the cloth is the same.